So to define a paired sample t-test and understand that the P is capitalized, the S is capitalized, and the T, just like in all the others, the T is in italics, it's lowercase, with a dash and a T-E-S-T afterwards, all lowercase. So if we're examining two sets of data, okay, generally it's done in a pre-test and a post-test. And this is done so you can examine one point of data compared to another point of data. This is no different than some of the other ones where you don't have all the information, you don't have the confounding variables like you had as we talked about last week. You're basically looking, is something better or worse than when you did the first test? So here's an example. We do a pre-test. And this could be on anything. It could be previous data. It could be anything. It's a set of numbers. And the pre and the post test need to be equal or your numbers are a little skewed. This is what you call lively and validity as maturation. If you're working with someone and they fall out, you can't have, if you don't have the post test, then you don't have it. You could be looking at numbers in a hospital. You could be looking at almost anything that has a pre and a post test, but they have to equal in some ways. It has to be the same. Okay? So you start with the pre-test, you give the pre-test, you get your data for the pre-test. Generally there's some kind of intervention. You're looking at whether you're just looking at is what are the things that are done during this time that were different than when you did the pre-test, or you may just keep it the same and then run a post-test later to see if you did nothing, what would happen. You can then run another whole series of tests. There's a period of time. It can't be a day. It can't be two. It's got to be more than that. So understand that. So you do your intervention and then you do the post-test. Now that moves us on to our last step. Your reporting, in your write-up, you will be looking at a correlation on top of the paired sample. So you will look to see the strength and the direction of the two variables. You're not running you're not running a scatter plot, you're not doing any of that, you're looking at the number, you're basically writing it out with the numbers and that. You're not doing an R2, you're not doing anything else. But then when we go to actually do the conclusion, once you've reported your correlation, that's over. You're reporting the means, not if they're statistically different from each other. That goes to the hypotheses. You're drawing a conclusion on the means. Give you an example. Test 1, mean equals 100. Test 2, mean equals 75. The conclusion of this test 1 score is higher than test 2 score. All you have to say in this, because in your discussion you are going to dive into this at a different level. So anything else, it doesn't matter if it's statistically significant or not. It should statistically significant should not be in your hypotheses or in your you're looking at the difference in the means. It shouldn't be in your introduction anywhere. The only way the statistically significant goes is to whether you're accepting the hypotheses or not. And this is your introduction.